Nepal holds a PhD degree from the Friedrich Schiller University of Jena on mountain hydrology.
Okay, thank you, Subina. Can you see my screen?
Yes.
Yes, we can see.
Okay, thank you. And good to see some of the colleagues, although because of the COVID situations, we are presenting here as a virtual platform. And I would like to welcome you in the Landslide and Sediment Transboundary Working Group session of the annual dialogue of Koshi Disaster Knowledge Hub. On behalf of the anchor group at ICIMOD, I'm presenting this and trying to give you an overview of the landslide and sedimentation and then the objective of our transboundary working group. It's most of you already know Koshi is a transboundary basins extending from the high altitude of Tibetan Plateau and then further coming to mountains in the southern Himalaya of Nepal and before merging with the mighty Ganges and pass through the Indo-Gangetic plain. As you see the topography, the issues are also, the wide range of issues the Koshi is facing, and one of them is the landslide and sedimentation is also a major issue.
Santosh, sorry to interrupt you, but we have lost your screen.
Okay. Can you see my screen, Kripa? Yes. Okay. Oh, yeah. Rajiv, you see my second screen?
We see Kochi's screen.
No, we are getting the introduction screen of the workshop, and that's it.
Okay. Now we can share.
Huh? Okay, thank you, Rajiv, letting us know. I'm trying to fix this now.
Yeah, we got it now.
Okay. So I'm showing this second slide with the Koshi Basin map. And here in the landslide and sedimentation is one of the major issues in Koshi. And it's not an isolated issue. If you look at it is deeply interlinked with other hazards such as floods. And then the issue also affects the lives and livelihoods in the basin because of all sort of hazards it can bring, for example, landslide, flash floods, and other kind of things. And some of the inventory already indicates more than 6,000 landslides in the Koshi River Basin. And alone, if you look at the 2015 great earthquake, it also caused more than 1,000 landslides in the Koshi River Basins. Sediment is a major issue, and some of the studies already indicate that 100 million tons of sediment is transported from the Chatara. And then out of these, about 50% of the sediment is actually deposited in the Indo-Gangetic plain. And this is the main cause that the Koshi has shifted its course in nearly 100 kilometers in last 250 years. And this has also caused a lot of embankment breach in the past years. And if you recall the embankment breach in 2008, which was the measure in which the river, the Koshi, changed the course to the old path and caused a lot of damage, both life and livelihood. Climate change is again a major driving force in the basin, and it has the potential to exacerbate many different disasters in the coming years, from glacial lake outburst flood to flash flood and other kind of perennial floods. If we look at from the upstream downstream context, then we see that Koshi actually represents quite a the upstream downstream dimensions in which the the glaciers and snowpack and melt runoff contributes from the upstream areas, and then a lot of landslides, sedimentation, erosion is happening in the midstream areas. And if you look at the downstream areas, for example, in the Bihar part, the sedimentation is causing the rivers to wander and meander. And that's what we see in the earlier picture. While the river moves from upstream to downstream areas, there are always threats in the form of different hazards, but there is always opportunities. For example, agriculture, hydropower, and all the different kind of opportunities also present in the Koshi. So I think the upstream downstream context is very, very relevant in the Koshi River Basin. Because of this realization, Sedimentation and Landslide Transboundary Working Group aims to improve knowledge networks and enhance transboundary cooperation among the partners on landslide and sediment related issues in the basin. So that is the objective of the Sediment and Landslide Transboundary Working Group. The areas of cooperation is the identifying the main causes of sedimentation and landslide in the basin, assessing their impacts on people, livelihood, economy, and developing possible solutions, not only addressing the problem, and also sharing the good practices among the networks. So this is the aim of the Sedimentation and Landslide Transboundary Working Group. The group was formed a few years back as a part of the Koshi Disaster Knowledge Hub. At the moment, we have 39 members from 5 different countries. We are still trying to push more female scientists and practitioners in the group. The Transboundary Working Group members meet regularly to update on research, identify potential collaboration opportunities. For example, we also worked on the joint proposals a few years back. As a secretariat, ICIMOD also shares the regular updates on studies and research done by the different thematic working members. And thematic transboundary working members are currently working together also on the multi-hazard assessment at the Koshi Basin. These are some of the pictures. The inception workshop of the Koshi Disaster Knowledge Hub was done in December 2018. And in July 2019, we also did the country chapter meeting. This is the lower one is from Bihar in India. And we also had a country chapter meeting in Nepal in September 2019. And then this has also established and strengthened the networking among the different groups, researchers, and practitioners. The priority areas for the Sediment and Landslide Transboundary Working Group, which is kind of reflected in the Nepal country consultation, is the science to policy, collaboration with research-based institution, and then also identifying the major research scoping areas like sediment budgeting, water yield, erosion estimation, landslide, and also to look at and work on the practice to science, early warning systems, for example, landslide early warning system, upstream sediment control and associated benefits, river system approach, and other bioengineering and low-cost technology. But also at the end, supporting the science policy practice and vulnerable communities living in the vulnerable areas, gender disaggregated impact, and inclusive practices. So here we are pretty much emphasizing the gender inclusive JC approach and livelihoods which can be impacted by the sediment and landslide. Today, I'm very happy to welcome you again on the session on landslide and sedimentation in the first annual dialogue of Koshi Disaster Knowledge Hub. In the next few hours, we'll be sharing with you we have 3 parts in our session. One is the research update. So we have 4 presentations from China, Nepal, Germany, and India. We have sharing good practices on mitigating and adapting to sedimentation and landslides. So we'll be hearing the 2 very local level good practices from Nepal and China, and we'll also discuss this kind of replicating this kind of efforts in the larger Koshi Basin. And we have a very interesting panel discussion on the need for regional cooperation on landslide and sedimentation research in the Koshi River Basin. So our panelists for today are esteemed panelists are Rajiv Sinha from India, Professor Nincheng Chen from China, Dr. Badridhaj Dongara from Nepal, Dr. Rajendra Bhandari from Nepal, and Kripana Srestha from Nepal. And then at the end, we'll give this summary and concluding remarks. This is my last slide. I would like to leave with the thoughts that although we see the sediment as a very small particles, nearly like in the range of 1/3 of our human hair, but the potential impact of the sedimentation can be observed very well even from the space. Here you see in the Bay of Bengal, nearly 200 kilometer, outside from the sea shore, there is the impact of sedimentation is very visible. And where does that sediment come from? This is of course coming from the upstream areas and then the upstream landscape. And there are a lot of activities happening from the infrastructure development, from some natural calamities, which are actually contributing to these the sediment sources. So both from natural processes as well as the anthropogenic processes. So with keeping this in mind, I would like to end my presentation, and I would like to once again welcome you for the session. And now I would like to pass to my colleague Subina to take the session forward. Thank you.
Thank you, Dr. Santosh, for setting the overview of today's session. As said by Dr. Santosh, the first sub-session that we have is on research updates, and to conduct this session as a facilitator, I would like to invite Professor Rajiv Sinha, who is the head of the Department of Earth Sciences at IIT Kanpur, India. He obtained his PhD in fluvial sedimentology from the University of Cambridge and is one of the leading earth scientists from India who specializes in earth surface processes and river science. He is also collaborating with Koshi for sediment projects and is a founding member of the SLTWG here at KDKH.
Thank you, Subina. Good to be here, and good to see so many friends from different parts of the world. So good afternoon to everyone, and good morning to my European colleagues. So it's a pleasure to be here. It's a group which has been working very, very efficiently for the last couple of years, and we are looking forward to a very exciting session. We have 4 talks in this session. And they will be covering different aspects of landslide and sedimentation in the Koshi Basin, which is one of the major problems which has been recognized by several workers in the past as well. So it is my pleasure to invite the first speaker for today, and that is Dr. Basanta Adhikari. Old friend of mine, but he's an assistant professor of engineering geology at the Department of Civil Engineering at Pulchok University of Engineering at Tribhuvan University. And he has also worked as a deputy director at the Center for Disaster Studies at the Institute of Engineering. And he has done his PhD from University of Vienna and has very, very long experience of working with different people across the world on aspects related to landslide, geology, and sedimentation. So welcome to Basanta ji, and please share your screen and start your presentation. Thank you.
Thank you, Professor Sinha. Am I audible?
Yes, very much.
Yes, Basant, we can see your screen. Please share. Yeah, Basant, please go ahead.
I would just like to announce before you begin that all the presenters are requested to note the time. The maximum time allowed is 15 minutes, 12 minutes for presentation with 3 minutes for question and answers. Thank you.
And I have the unpleasant job of stopping you guys.
Okay. So is my slide visible, Professor
Yes.
Sinha? Okay. Thank you very much. It's wonderful to be here with my esteemed colleague around the globe. Today I will highlight some of these activities that we are doing, mostly on building up landslide disaster resilience in the mountainous communities, mostly focusing on Himalaya. But today I'm going to present some of the activities, particularly in Koshi Basin. So you can see this picture where I took picture from Okaldunga. You can see the large landslide, and then the sediment generation downstream. But in the uphill side, you can see the beautiful village which is in danger. So we need to think about this landslide study and mitigation. But let's look this data spatio-temporal variation of this fatality event from 1971 to 2019. I'm just plotting in the middle of Koshi Basin from Nepal. So if you look the data of landslide fatalities around 1542, and we lost more than 1900 people in that region. So the red dots actually denotes the area of landslide, whereas in the flood, total fatality flood event is 1993, and we lost more than 1900. So these are the actual scenario that we observe only in middle part of Koshi Basin in Nepal, and there are lots of other data in Indian part also which I don't have access. So I just try to give some glimpse of what's the actual disaster scenario over there. But as Dr. Santosh already presented or mentioned about the sediment generation in the mountains, you can see these are some example from Okhaldunga district of Nepal, where these sediments or the landslides are generated due to natural events and then the anthropogenic events like the road construction and others. So these are the actual sediment source that flows downstream to the Seti River and ultimately to the Bay of Bengal. So these sediments, when it travels to the downstream, here you can see this river aggradation in some of the rivers in Nepal, like Hadiakola, Ratkola, Gogan, and Khado. You can see the aggradation is there. So I visited this place back in 2014, and you can see, sometimes the bed level also raised, pretty much 1 or 2 meters. So ultimately creating the flooding problem in that area. So, realizing these things, what are the problems or sedimentation and landslides in that area? So these are some drivers and pressures and impacts. So, for example, land use change or land cover change, or intensive agricultural practices, natural processes, and climate extremes are the major drivers. And then it, triggers the erosion, sedimentation, and land degradation, and ultimately impact on loss of productive soil, and also impact on hydropower and changes of river morphology. And, the Koshi is one of the most affected for these changes in river morphology. So, when you understand this driver, pressure, and impact, I will show one of the study done by Professor Sinha and colleagues. Here you can see the basin scale hydrology and sediment dynamics in the Koshi River, starting from this Chatara to Birpur, which is the border between Nepal and India, and ultimately to the Baltara, where you can see this annual and sedimentation sediment deposition in metric ton per year. So you can just imagine the scale of that event or the sedimentation process downstream in this Koshi River basin. So these are some examples which showed you the status of the interaction between the landslides and sediment generation in this Koshi River. In 2018, we tried to understand, what's the relationship between landslide and road construction. That we did our study in Sindhupalchok district, which is nearby Tibetan border of People's Republic of China. Here you can see that most of the landslides were generated around 100-meter side of this road. So these are very consequences of these non-engineered road construction in that areas for generating large scale landslide, but mostly small scale landslide most of the time. So after having this study, and then I was heavily involved how to design mitigative measures on community-based or community level, what we called community-based landslide risk reduction approaches or CBDRR approaches. Here you can see that I was, explaining to our local community about the landslide in their own language. It means in Nepali language. In the first picture, you can see that I was just, drawing some landslides, showing some of the features, and then I and my colleague were trying to, teach them how to use this total station to prepare the landslide engineering map, and then talking with the local community, what we called participatory rural appraisal, so PRA tools, and trying to understand what really going on, and collecting the historical information on that area. So these are some examples that what we have done in the past. But after these CBDRR practices, I will show you some of the example here from eastern part of Nepal, eastern part of Kathmandu. Here you can see this is the primary house, and these the river or the small channel here, and then you see the slope failure due to, or bank cutting due to this the water in the rainy season. And then people were afraid of losing this school, primary school, which is one of the important part of their community. And then we went and trained, and they worked by themselves, and then they used some bioengineering practices like Gavin wall and slope modification and some bioengineering practices. And here you can see another reference example that how we can use this small scale intervention like $3,000 to $4,000 and then community can change the disaster scenario on that area. So another example also from Sindhu Palchok, here you can see that people are involving by themselves after having some little bit technical training given by us. And then the result is that you can see the old trail where people used to go for their farming and paddy field in the monsoon season, and they were afraid of losing their cattle, and it was really difficult to work. But after this intervention, these people were very, very happy because very small intervention. This is the only one example. They have replicated these things in other part of the districts also. So these are some community-based intervention. But when you look on the broader picture, here I'm showing some of our study published in 2019 about landslide susceptibility mapping in Sino-Nepal road corridor from the remote sensing, only using the remote sensing images in Kodari and Rasuagari, using this earthquakes and rainfall triggered landslides. And then after we went to the field, as you know that Nepal is being connected with China by 3 road, and I will just present one of the example from this Kodari highway along the Botikosi river. Here you can see this road just passing along this Botikosi, or later we call Sunkosi. I will show you some of the photographs that the actual scenario here. You see this is nearby Nylon in China. Here you see the landslide protection measures that they are doing just nearby Nepal-China border, where the landslide problems is one of the major threat over there. This is the most reoccurring landslide in Botikosi River, just nearby Borderland Hotel. If you go downstream, and this is the famous Jure landslide that occurred in 2014. So you can see this, the sediment generation and then travel, transported to the riverbed in Botikosi River. And here, my student from Nepal and China, they are measuring the displacement, vertical and lateral displacement by this creeping landslide in that area. So these are the some, the practical landslide study that we are doing. And then in a, extreme event, I just saw the one example. My colleague Christine and Christoph will present after me about this glacial lake outburst flood in the Botikosi River. Just one example here. You will hear more from them later on. And then we tried community-based landslide early warning system.
10 minutes are up.
In Nepal, where we established the early warning system, and my colleague Prakash Singh Thapa will present later in this section, so he will explain a little bit more on that. So what are the ongoing activities that we are doing? So we are working on landslide inventories, and we have started documentation of ecosystem-based disaster risk reduction intervention in the Koshi Basin, and we are preparing some proposal on that. And we are working on climate projection and effect on landslide and sedimentation. And then, of course, the landslide risk perception along the Sino-Nepal road corridor along the Kodari highway. So at the end, such kind of landslides or the rock slides we are facing in the mountains. So we need to work collectively for building disaster resilience. Thank you very much. I will be happy to have some questions if there are.
Thank you, Basanta ji. Santosh, shall we have some questions now or shall we take it up later? What's the model?
Yeah, Rajiv, we have 3 minutes, so we'll see if there is a question.
Yeah, if there are some quick questions for in the next 3 minutes, we can go ahead. And then, of course, we'll have some time left in the end of the session for a larger discussion as well. Please go ahead. You can either raise your hand or just switch on your camera. I am also watching the chat box, but there isn't anything at the moment.
Yeah, there is.
Okay, can you hear me?
Yes.
Yeah, I wonder, in India, the community-based warning system is very important in China. I like you to introduce me the community-based warning system. In China, every inch of the landslide site, the government supports some money to the local people use the community-based warning system. But in India, how much area have this kinds of system?
Thank you, Professor Singh. I don't know exactly in India, but I can say, tell you from Nepal. So we are started doing this community-based landslide early warning system, and we have piloted and successfully in Nepal. And we spend more, for example, $4,000 to $5,000 and it worked perfectly. And my colleague Prakash Singh Thapa will explain details on that later on.
Thank you.
Okay, anybody else? A quick one. Okay, I can see Rajendra Bhandari ji. I can see your hand raised. Bhandari ji, do you have a question?
No, sorry, I didn't have any question.
Okay, I saw your hand raised, so that's why I asked.
No, thanks.
Okay, all right. So if there are no further questions, let's move on to the next talk. And the next talk is to be given by 2 colleagues from Potsdam, Dr. Kirsten Cook and Christoph Andermann. Both of them work at the German Research Center for Geosciences. And Kristen actually works on understanding the erosional processes and process interactions in natural systems. And she holds a PhD degree from MIT. And Dr. Christoph Andermann is a geomorphologist, and he also works at the German Center for Geosciences. I believe this talk is to be given jointly by Kristen and Chris. Is that correct? Right.
Yes,
all right. So who goes first?
I think I go first, but I'm not sure
Chris, go ahead.
I managed to share my screen. I think I kind of didn't give permission. Maybe Kristen can do that for me.
Subina, can you help?
Just a second.
Yeah, I'm sorry for that.
No, I mean, there may be some permission.
Solution, I was just quick checking. The solution would be to quit everything and come on back again, but I think this is a bit risky. Yeah, so maybe I start already talking while this is coming on.
I will share the screen on my end.
You have the presentation? Okay. So, Christoph, Subina will show the presentation from our side.
Yep.
And you might just need to indicate the next slide when you want to move.
Yeah, I will do that. So, hello, everybody. Sorry for this little delay. This is not my presentation, but it's also a nice picture. I think we see now Santosh's presentation.
Yeah.
Anyway, so thank you, everybody. Thanks for the organizers and thanks for the panel to set that up on is happening. As Rajiv already introduced, my name is Christoph Andermann, and I'm giving the first part of a shared presentation. We're going to talk about monitoring landscape response to extreme events in the Koshi Basin. So this is a little bit more an overview on what we are doing in the Koshi Basin itself in Nepal. It's not really conclusion driven. It's more an overview on our activities and techniques we apply here. I think this is the most valuable for this kind of meeting here. So can you, on the picture before you saw the Upper Bodekoshi catchment along the Aniko Highway, and there was a landslide actually happening during an aftershock of the Dolkha earthquake 2015, and this earthquake was one of the motivations that we started working in the Koshi Basin. So we are actually interested in to understand how the earthquake perturbated the landscape there, how it affects different processes in the landscape, and how long this takes to recover back to a quasi background or steady state situation. So we set up quite quickly, also with the help of Basanta Adhikari, a quite dense network of monitoring. You can see here on the map, all the blue stations are river gauging stations where we installed discharge measurement and also trained people to take samples on a daily scale for us and prepare the samples, and then they were shipped to Germany for further analysis. And we also installed in a smaller subsetting within the Upper Bodekoshi catchment. So next slide, please. Yeah, we set up a smaller, more dense observatory of seismic monitoring, and this is on the western side of the Bodekoshi, or actually on both sides, but it's more on the Kahule Kola, which is a little bit upstream of the borderland resort, just downstream of the border with China. Several seismometers to actually monitor the landscape. We are not so much interested in earthquakes and aftershocks itself with the seismometers, but everything that moves and deforms in the landscapes generates noises, and that can be recorded on seismometers. And so we were actually interested to monitor how the activities are behaving in this landscape and if they are changing over time as further we get away from the earthquake. So we set up 12 seismometers and then also a couple of weather stations. And this whole thing was also accompanied by one gauging station in the Kahule Kola, which is the small catchment you can see on the map. Then please next screen. So the techniques we apply, we have a couple of tailor-made equipments, and they're specifically designed to our work. So from our experience working in the Himalayas, we built our own equipment. This is, for example, this filter kit you see here on the left side. There's also, this is really handy. It's a small hardcover box, and it's easy to deploy, and we can train people in the field really quickly how to use it. And then they were doing this for 4 years every day and provided a really unique time series to us. Then we have our own type of monitoring systems or stations. We here collaborate also with RTS, real-time solutions in Nepal, who mainly maintain some of the stuff for us, or also build up some of their systems, and we adapt them to our needs. And we also used discharge measurements to develop rating curves, and we had for a while an ATCP stationed in Nepal, and that was taken out from all kinds of research groups to get background information on discharge to convert level measurements into real discharge measurements. Next slide, please. So this is an overview on some preliminary results concerning the discharge, landslide mapping, and sediment measurements. So on the right top, you see a figure of a published paper from Oda Mark in 2019, where we looked at the rate of landsliding, how it developed over the earthquake. Like we mapped from available archive satellite imagery the rate of landsliding before the earthquake on a typical monsoon, and then what happened during the earthquake, like what happened co-seismically, and in the monsoon after the earthquake, and the monsoons that followed on until 2018. And you can clearly demonstrate the earthquake itself was worth several monsoon seasons in terms of landsliding activity, but also the monsoon season 2015, which was actually quite weak, was quite enhanced in landslide activity, more than 2 sigmas of the background noise. But what we also could see is that the enhanced landslide activity developed quickly back to a background noise. So the landslide, the earthquake itself, even though it was very strong, it kind of seems to have only 1 year of impact on the whole system. Similar, we see here on the left side, there's 2 panels. The upper one is discharge. It's a bit longer, sorry for that. Then the lower one, that is sediment flux, calculated from our own observations at Kurkot on the Koshi, somewhere central of the Koshi Basin. It's a couple of kilometers downstream of the confluence with Tamakoshi. And here we see clearly that discharge wasn't really elevated during the monsoon after the earthquake. So the first discharge curve, or the first hydro curve, seasonal hydro curve there. But sediment flux was much more enhanced. And then we see also on the 2016 a really high spike that was the Glacier Lake outburst flood that we also recorded with our seismometers and all our measurements. But Kristen will continue on that. So I hand over to Kristen. Thank you.
All right, thanks. I hope everyone can hear me. Yeah, you could go to the next slide.
Next slide. Next slide.
Yes, and Cook also from the GFZ. Oh, you could go back one. Yeah, okay. Yeah, so I'm going to expand a little bit more on some of the other techniques we've been using and some of the results we've seen. And so the first of these is why we put seismometers in our observatory. And Christoph mentioned this just quickly, but the reason is that pretty much any geomorphic process will make seismic signals. And so things like landslides, debris flows, also just flow in a river, and the transport of bedload or coarse material in a river. These all make seismic signals that we can measure. And so with our network of seismometers, we can detect events like landslides and debris flows. And then we can, with this detection, we can know exactly when these happened and then relate these two potential triggers. And so here I'm just showing a nice example. On the right, there's a picture of this debris fan that formed in 2017 right next to one of our stations. And on the left, we can see the seismic record of that event. And what's really nice about this method is that you can see multiple types of events with one record. So for example, we could see here this debris flow coming down and forming the fan, and then we can also see the transport of this material in the Koshi River for some days afterwards. And then the other big advantage of this seismic method is that we don't have to put anything in the channel or even very close to the channel. So for example, when a big flood comes, it might destroy all of the instruments in a channel. as we can see on the upper right here, that the seismometers will stay safe because they're some distance away. Okay, so next slide. Yeah, so this was convenient that these instruments don't get destroyed by big floods because, as Basanta mentioned, we also were able to record this glacial lake outburst flood that came down the Bodakoshi Sankoshi in 2016. And so with the seismometers, we can actually track the flood as it moves downstream, which we can see in this figure on the upper right. We can see exactly how fast it moves. And we can we can track its evolution. We can also, maybe more relevant for this session, on the bottom right, we can also track the amount of sediment that's being transported, or the coarse sediment, the bed load that's being transported. And this is what the black line in the lower right shows. So this is the increase in bed load transport for the 10 days following this flood. And then the orange line is actually the suspended sediment concentration from our measuring station. So we can see that the GLOF not only transports a lot of sediment during the flood, but also afterwards, it's perturbed the channel, and it takes some time to recover. And then the other really nice thing about the seismic data is that we can actually detect this GLOF, and we've seen in a couple other examples other GLOFs, from long distances away. So the 2016 GLOF started in China, about 20 kilometers upstream of our network. But we can actually start to detect it even from its initiation. So stations 25 kilometers away and stations 60 kilometers away record the signal of this flood. So this opens the potential for long range detection and potentially early warning of GLOFs, which would be pretty exciting. All right, so next slide.
1 minute remaining.
Okay, we'll go fast. Yeah, so this slide is just to emphasize that one of the things we don't hear often about with floods is their effect on the hill slopes and their role in triggering landslides. And so this 2016 GLOF triggered a lot of landslides. If you look at landslides just next to the river, it's about 100 times a normal monsoon. And this was actually, aside from a destroyed hydropower station, this was the main source of damage from this GLOF, was lateral erosion and landsliding. So this is something we maybe want to think more about when trying to predict landslide hazards. Okay, next slide. Yeah, and so another monitoring technique we've been doing is doing repeat terrestrial laser scanning. So we're kind of trying to track the movement of landslide debris, both from the earthquake and from the GLOF, off hill slopes and into the river. So we can do very high resolution change maps and see kind of exactly how landslide deposits are evolving. And we've done this for 4 years. We plan another survey, hopefully, if we can travel to Nepal this year. And then next slide. Yeah, so we're doing this both for the landslide, the co-seismic landslide deposits, and then also tracking the evolution and hopefully eventually the stabilization of some of these GLOF-triggered landslides next to the river. A number of these have still been sliding for some years afterwards. Okay, now next slide. And this is the last one, just kind of a summary of what we've been looking at. And it's really the first point that I want to emphasize, that this kind of integrated monitoring network that we've built and have been using is really useful to, I mean, we can track processes from the landslides to the delivery of sediment into the river, and then eventually the delivery downstream all the way to the mountain front. And so to understand kind of how sediment is generated and transported in the Koshi Basin, these kinds of integrated networks are potentially really useful. So I will stop there.
Thank you, Christine and Chris. Very interesting and very innovative approach for looking at the landslide and sediment measurements integrated way. So we'll probably come back for questions a bit later because we are just about time for the next talk. So we'll probably have enough time. I think this is a talk which needs a lot of discussion, I'm sure, but we'll come back to this. Thank you so much for your interesting talk. So the next talk is by Dr. Kanchan Mishra, and she, worked with me on the Kosi Basin for her PhD. She is going to talk on the hydrology, sediment dynamics, and sediment connectivity of the Kosi Basin. This is one of the first integrated study on the entire basin. So, Kanchan, can you start sharing your screen?
Yes, sir. So am I visible?
Not yet.
Okay.
Kanchan, you need to share your screen.
Yeah,
yes.
coming.
Now this is visible?
Yeah, sure.
Okay. A very good afternoon to all of you. And I'm Kanchan Mishra, a PhD from IIT Kanpur, and I have done my PhD under the supervision of Professor Rajiv Sinha. So I will be talking about the comprehensive work that we have done in collaboration with ICIMOD on the topic sediment dynamics and sediment connectivity in the Kosi Basin and its implication over the river hazard. So as we all are familiar with Kosi Basin, and it has a very large catchment area and almost 7 rivers that is being flowing from north to south direction, joining at Chatara and getting debouched in the low-lying plain of Indian part. So when we talk about the sediment dynamics, which is as mentioned by Dr. Santosh also, that it is one of the central problem in the Kosi. These are the part of hinterland characteristic along with these tectonic causes, precipitation and runoff. These all led to the increase and contributes to high sediment flux and also changes the river dynamics. These get resulted in the form of bank instability and erosion, and the sediment flux led to aggradation or degradation of the channel or river segments. Along with this, we have the human interventions in the form of road networks, even embankments and the railway tracks. This led to the congestion, and this ultimately led to the flooding in the low-lying areas also. So considering these cause and effect, the important characteristic that Kosi Basin has a high sediment supply and a huge amount of water discharge that is coming out, along with the frequent flooding in this region. Considering this important characteristic, we have three major research focus. One is hydrology and sediment transport characteristic. Second is the basin scale sediment connectivity analysis, and third is flood risk assessment of the Kosi Basin. These all research focus has a very comprehensive work, but I'm going to highlight few of its work and the results. And this has also been published. The entire work has also been published in the peer reviews. So the number one is the hydrology and sediment transport characteristic. And For this, the entire data, almost of 4 to 5 decades, have been used from Nepal and India, and still it is not present in the or available in the literature for the entire Kosi Basin. And we have tried to understand what is the upstream and downstream linkages by analyzing all these data sets, whatever is available. And as we can see that we have used multiple approaches to understand the rainfall, discharge and sediment data. What is the variability in terms of its spatial and temporal scale, and what is the interrelationship among them. So we have also compiled the sediment available sediment load data for some reaches, and we have also calculated the first order sediment flux for this reach, and it has also helped us to understand how this has led to river avulsion and flood risk. So I'm going to show some of the results. This is the heading of the rainfall and hydroclimatic analysis, and I'm going to show this the pattern of the rainfall that is being changes with respect to the latitude and longitude. And we can see that in terms of latitude, the middle part of the Kosi Basin is showing the higher amount of rainfall as compared to the low-lying the Indian part and the Tibetan part. In terms of longitude, again, the eastern part is showing, we can see that the eastern part is showing higher rainfall higher rainfall, and it is decreasing from west to east. Even we have plotted the different rainfall at the Baltara, which is the very downstream of the Kosi Basin at the Indian side, and we tried to understand what is the lag period between the rainfall and the peak discharge, and it has been come out to be 10 days, and this is mostly attributed to the groundwater recharge. We have also tried to understand what is the trend of the rainfall and discharge annually, and it has been found out to be 2.54 mm per year, and the discharge to be 11.5 meter cubic per year. Now, second is the discharge data analysis. We have a lot of analysis within this, but I'm showing only the hydrograph, and we can see that we have two different types of peak that has been coming out, and the this low and broad narrow peaks is of these region having this Pachwargat, and this is because of the high slope and low drainage density, and even the catchment area is also elongate in nature. But when we see the Baltara, the Birpur, we can see it's very rising limb and with narrow peaks, and this is because of the large drainage area, high and low slope. Basically, these the idea of the analysis is to understand the basin characteristic that is influencing the hydrological characteristic of the basin. So coming to this is also telling you about the discharge variability versus flood magnitude that defines the intensity of the flood. And we can see that the flood magnitude is rising very quickly in the Pachwar Ghat and as compared to the discharge variability. So we can see that that this is mostly the flood prone region, but Rabwa Bajar, this is considered to be this is the flood prone region, and this is the flood this is prone to flash flood. And when we come about the Baltara, this is in a very low lying area, and this is randomly, this is very periodic in nature in terms of flood. So basically these all tells you about the different geomorphic setting, rainfall and catchment area influence over the catchment. Now coming to sediment data analysis, this is telling you about the intensity of the different catchments with the available sediment load data. With the equation of SDRC, that is sediment discharge rating curve, we have tried to analyze what is the erosive power of each of these these discharge station, and it has come out to be that the Chatra, the Barak Kshetra and Bipu is supply limited because the erosive power is quite high in this region, whereas the sediment present is quite low. Whereas in Baltara, we have a tremendous amount of sediment, but the transport capacity is quite low. So we have also
Minutes are up.
yes.
8 minutes are already.
Okay. So this entire work has been published in the Journal of Hydrology. The next is the basin scale sediment connectivity analysis. So basically, this is the idea of using the connectivity index in the upper Koshi Basin. With the source data, we have the this C factor map that is being derived by the NDBI and the DEM using. Basically, this tells you about how the different catchment compartments are connected to each other in terms of sediment connectivity. So there are two types of connectivity. One is catchment connectivity and another is the hill slope channel connectivity. And we have plotted these two results in the form of PD plots. These are probability density plots in order to understand what is the influence of the different basin toward the sediment transfer. This has been further categorized into a highly connected, moderately connected, and poorly connected system, and all the different dominating controls have been analyzed along with this. This work has also been published in Science of Total Environment. Then next is flood risk assessment. This is a systematic concept where we calculate flood risk with the help of hazard and the vulnerability. So the entire data and methods have been discussed here. We have a separate hazard analysis where we have used the different remote sensing data, and here we have used the ancillary data using the census data and the field validation for field visit data. And we have developed the flood hazard index and flood vulnerability map. Together, by combining these two, we have indicated and generated the flood risk. And these are the results of this analysis. This is the hazard map, this is the vulnerability map, and this is the final risk map, which has been categorized into 4 zones. Then we have also calculated the statistics, and it is turned out to be that the hazard is almost hazard prone area that comes to be in to be 67% almost, and when we add the vulnerability, it turns out to be 63% altogether. So we have also categorized in this in a block-wise basis of all within this Koshi megafen, and accordingly we have also constructed some set of structural and non-structural measures to understand or to develop for the flood risk management of the Koshi Basin. This data has also been published and in the geomorphology under this title. That's all for this. Thank you.
Thank you, Kanchan, for keeping the time just about. We have 2 minutes, and if somebody has a quick question, we can take that. You can either raise your hand or just switch on your camera. Okay. I guess people are saving their questions to the end. That's fine. All right. So then let's move on to the final talk of this session. And this is being given by my old friend Bodo Buchhagen from Potsdam University. Professor Buchhagen is the chair and professor of geological remote sensing at the University of Potsdam. He is a very well-known worker in the community of the Himalayan geology. He works on various aspects of geodynamics, geomorphology, hydrology, and atmospheric processes. And most importantly, the interactions among them, basically. So, he has also worked quite extensively in the Central Andes and also the high mountain Asia, including the Himalayas. So, Bodo, welcome to this session, and he's going to talk on the climate variability, hill slope stability, and sediment transport processes in the Western Himalaya. So, Bodo.
Hello, everyone. My name is Bodo Kagan, and I'm going to present you some work from the Western Himalaya. So I am moving westwards from the Koshi River, but many of the processes that I'm going to talk about are very, very similar to what we have observed in the Koshi. And that is specifically applicable to the Arun Valley, where we also have worked for several years. Before I start out, I wanted to thank Rajiv and everyone else for putting this session together. I tremendously enjoy seeing the high technical expertise that is being used to monitor these very, very dynamic environments. So these everybody who works in the Himalaya knows how difficult it is to monitor some of those environments, and that's why dividing my presentation into several different time slices. I first talk about some present-day measurements and environmental gradients that exists in the Western Himalaya, but in that fact in all parts of the Himalaya. And then I'm shifting to the Holocene and late Pleistocene, and I'm doing that to make that point very clear that if we want to understand present-day sediment flux in the Himalaya, we need to consider the transiently stored sediment that sits up in the Himalaya at high elevations. And these are processes that have occurred during the Holocene and late Pleistocene. And I'm going to zoom into this in a few minutes. So let me quickly show you where we are at. We are located in the Western Himalaya. The catchment that we have worked in since 20 years is the Sutlej Valley, a tributary of the Indus. And that is in the drier part of the Himalaya. Let me walk through this transect. I have seen that very nice intro presentation that showed the different sections of the Himalaya, and I just wanted to pick up on this, point out that we have in the lower elevation regions here, the lower Sutlej, we have a large amount of transiently stored sediments in the form of fluvial terraces. So these are being stored and mostly climatically controlled, as we have shown several years ago. If we move into the high elevation regions, this here is in near Nanda Devi, roughly at 4,500 meters, looking towards the north. We are in a different environment where we have a much higher flux through the system and a lower sediment storage. If we go further north, an example would be the upper Arun Valley or the upper Sutlej Valley. We are beyond the orographic barrier, and we end up storing a lot of sediment in the river valleys. And this sediment can be very easily mobilized and is a high factor of natural hazards. So let's zoom into the Sutlej in the Western Himalaya. So you see in the black line the longitudinal outlining the longitudinal profile, and here on the right-hand side you have the relief. Note the yellow colors that indicate the high relief regions. This is the orographic barrier, and that catchment that I'm going to talk about a little is the Spiti, which is beyond the orographic barrier. In earlier work, we have looked at the sediment flux. We have just seen some very detailed and very high resolution sediment flux data after the earthquake, the Gorka earthquake. What I'm showing here is pre-Gorka, and the point I'm going to make is that there is a large influence of rainfall on sediment flux, and no one questions the impact of large earthquakes, but at a seasonal cycle, we clearly see that those red bars that indicate the suspended sediment concentration is highly correlated to summer rainstorms. I should also point out that here in the northern part, in Ganvi of the Sutlej Valley, we have a much higher ratio of suspended sediment concentration versus river discharge. So when it rains, it doesn't rain often, but if it rains, you have a very, very high suspended sediment concentration per unit discharge. The rainfall has a large impact on triggering rainfall, triggering erosional event, and this is shown here by this 20-year TRIM analysis, where we compare the median rainfall versus the extreme, the 90th percentile rainfall. And I just want to draw your attention to the higher, brighter colors. They indicate that the 90th percentile is 7 or 8 times as high as the median rainfall. So these regions here, particularly the Spiti Valley, is experiencing repeated extreme rainfall events, and they, of course, trigger significant sediment flux. Conceptualizing this, if we are looking at the orographic rainfall area, where we have continuous rainfall on the order of several meters per year, we have a thick vegetation cover that is also increasing soil stability in this part. If we look into the dry part of the beyond the orographic barrier, that would be the Upper Rhone or the Spiti Valley, we have a vegetation-free terrain that is not very cohesive. So if we turn on a big rainstorm, which we have observed several times, so you have an orographic rainfall migrating into these dry regions, you don't need much rainfall to trigger a tremendous sediment transport. So this is clearly a climatically driven process, and it, of course, would only be excorporated if you have earthquakes in this mix. Let me also point out that while we know that earthquakes and rainfall trigger sediment flux, we are also aware that the picture is a little more complicated. Specifically, if we migrate into permafrost regions, their temperature plays a big role. So this is a detailed time series going from May to July. And we note that when we have an increase in temperature, we increase the suspended sediment concentration. And that is mostly the melting process that occurs either due to the snow cover or due to the thawing permafrost in some of those regions. And that is not tightly correlated with rainfall. Again, the suspended sediment concentrations are low. This is only a small tributary, but that process needs to be taken in account if we want to be able to more precisely predict sediment concentration changes through time, especially in the light of climate changes. Okay, let's zoom into the Western Himalaya, the longitudinal profile here of the Sutlej Valley, going from roughly 5,000 meters down to a couple of 100 meters. And what you see here on the right-hand side is the relief surrounding the Sutlej, and the red colors indicate a very deeply incised gorge. And I'm going to talk more about this upstream region here, the blue-greenish colors. This upstream region is where you transiently store sediment that then gets repeatedly transported downstream through this channel and has a big impact here, even in the very far downstream section. So that high transport capacity that exists in the steep part of the Sutlej Valley allows to transport the excess sediment from the upstream part. So this is essentially the Sutlej, as well as other rivers, form a conveyor belt that transports sediment from the high elevation regions to the low elevation region, in addition to all the sediment that is being produced in that steep section here. Let's look at some cosmogenic radionuclide rates that have been published in the past years and that are still in process. If we look into the upstream section, we have erosion rates of 0.2, 0.3 millimeters per year. If we go into the high erosion, the steep regions, so for example, the Baspa Valley, we have an erosion rate that is significantly higher. And on average, at the outlet of the Sutlej, we have roughly 1 to 1.2 millimeters per year erosion rate. These are cosmogenic radionuclide rates based on aluminum and beryllium river sand cosmogenic nuclides. In the upstream section of the Spiti, we have sampled those terraces, and we were interested in dating those terraces to better understand the formation process of these terraces. We have been digging holes and wells in order to get to the deeper samples, and I'm not going to present these data in detail. This is in an upcoming paper. I'm just pointing out that the several terraces that we have dated, they all fall into the pluvial, the wet periods of the past monsoon. And we are specifically happy to have successfully dated the last interglacial period. So we observe terraces that have been generated 120,000 years ago. The preservation potential in that part of the Spiti is fairly high. We would not be able to preserve these in the steep section of the Himalaya. One very important formation factor are these landslides. And now I need to make a clear definition here. We have heard about landslides, and no question, all those landslides that we have seen in the past talks, these are landslides. Yes. What I'm referring to here are deep-seated landslides. These deep-seated bedrock landslides, they exceed volumes of 1 cubic kilometer, and they have been impounding rivers for several thousands of years. This is an example from the Baspa Valley, and if we go to that dam that is now being eroded, so essentially the plug that the landslide generated, and we look downstream, this looks like a very, very steep hill slope, but in fact, it is in the midst of a larger stream, and these are the remnant of a Holocene landslide that we observe. So along this course here, we are doing repeated surveys to better understand what the sediment transport processes are. You, of course, also see the impact of the hydrogenic structure here in the on the right-hand side. So in the past, we have dated those large landslides, and we can show that the landslides fall into the pluvial, the wet periods, so when the monsoon has been intensified, and also migrated deeper into the origin. So we have the enhanced monsoon period that could then repeatedly trigger those landslides. And, we were always wondering, why would we trigger landslides specifically in those wet periods? Well, of course, you can increase the pore water pressure and reduce the cohesion. But there is another very important factor in there that we just recently noticed, and that is that during those times of landslide triggering, the river valleys, including the Spiti Valley, they were without transient sediment storage. So in other words, all those nice filters, I need one more minute. So all those nice fill terraces that we have in the upper Spiti Valley, they have been removed 8,000 and 9,000 years ago, and that allowed to trigger the landslides, because now we are eroding bedrock, and those big landslides then impounded a large amount of sediment, and these are currently being eroded. This is a high natural hazard because these are unconsolidated sediments that rapidly can be moved downwards, for example, through glacial lake outbursts, as we have seen in the Sutlej, but also in other regions. Okay, thank you very much for your attention.
Thank you very much, Bodo. Very interesting, and you brought in a very new perspective to the landslide research, and of course linked it with the sedimentation patterns and concentrations, and of course distribution of these scenarios over time. I think it's a good perspective to look at the long-term data sets to be able to understand what's really happening in the present time. So I'm really happy to see that all these 4 talks, really excellent talks, and they brought in a very different perspectives, starting from the community-based landslide, responses to basin scale hydrological processes, and then of course looking at sediment dynamics and connectivity, also looking at the modern tools which are available to us. Particularly, I was very impressed with the seismic work, particularly, which is going to be very promising in areas like this, where a lot of the reaches are inaccessible, and we always have this risk of losing the instrument. So I'm sure people will have lots of questions about any of these talks. So I'll open the discussion session now, and we have maybe 10 minutes or something for a discussion. So please raise your hand, or just go ahead. Yes, Bodo, I can see your hand.
Yeah, thank you, Rajiv. I have a question for the first couple of speakers, and that is the research or observation of slow-moving landslides. So one thing that we have observed in permafrost regions throughout the world, in the Pamirs and the Central Andes and also in the Himalayas, are slow-moving landslides. So I'm not talking about a thin sliver of unconsolidated soil that is moving downwards. I'm talking about a deep-seated bedrock landslide that maybe moves by centimeters or meters per year. And I'm wondering if those are being observed and if there are examples for that in the Koshi Basin, because I'm certain that they would pose a significant threat once they are being triggered and potentially also impound rivers.
Okay, would somebody like to take this question? Either Basanta ji or Chris?
I will just address that one. Thank you. Very interesting. We have, very large, deep-seated landslides in the Himalayas. We observe in the Western Himalaya nearby, not Western Himalaya, but in the Karnali region. But in the Koshi Basin, I don't have that much idea, but not that scale that Bodo you presented on very slow-moving landslides, but not that fast, but in medium type of slow-moving landslides we have in Koshi Basin, especially in the Arun River Valley in the upstream. Maybe Chris will address some of these issues. Thank you.
Yeah, thanks, Bodo, for your question. There is one very prominent and recent example. It's the Tura landslide, which is on the upper Sunkoshi, just when the Sunkoshi becomes Bodekoshi, if you go upstream. And you could see that this one was deforming for a couple of years. Of course, we observed this only because it has failed, and then we looked more closely into the satellite imagery. And then it actually failed in 2014. So this is kind of a picture book example of what you're asking. And it's also, if I'm not wrong, in the order of a square cubic kilometer of dislocated sediments. It's actually that big that it's bigger, or it's more volume displaced than it has been displaced from all this widespread small-scale landsliding during the Gorkha earthquake in the upstream area of this particular valley. If you take the whole Gorkha earthquake, then it's of course a little bit more than that. It's an important question what you raised, because in this paper by Audin, what I shortly cited, we also saw that if you look at erosion rates estimated from suspended sediments or from cosmogenics or from geochro, that there is a discrepancy, and that like the geochronology erosion rates, they show really high erosion rates in average, several millimeters, and then cosmogenic is somewhere in the immediate, and the suspended sediments is even less than that. So there seems to be different processes that maybe are not captured if you look at processes only today. And actually what we showed is that you really have to use or look at these huge landslides to make these sediment budgets working.
Thank you, Chris. You also have a question, Chris? Or sorry, Chris, do you want to add something?
Yeah, I want to add, in addition to the giant landslides, there is, in the Bodekoshi, in our field area at least, there's a lot of slow deformation on a bunch of the hill slopes. How deep it is and whether there's any bedrock in there, we can't really be sure. But yeah, there's a number of pretty large slopes that are kind of slowly deforming. And one of the interesting things we saw after the GLOF is that it seemed to activate some of these slopes and they've remained active for years afterwards. One of the more interesting ones was actually last activated in 1981 after the previous gloff on the Boda Koshi. So there was a slope and there was a village that was destroyed by sliding after the 1981 gloff. It slid for a couple of years, then stabilized, remained stable. The village was rebuilt on it, and then it again started moving and has moved tens of meters since the 2016 gloff. And so, yeah, I mean, these aren't the cubic kilometer scale, but there's a fair amount of slow movement going in these areas. And it's tricky because you don't see this on satellite imagery. So it's hard to constrain. You won't see it when you're mapping landslides. So it's, yeah, I think it's an underappreciated part of the system.
Yeah, that's nice. Thanks, Chris.
Yeah, thank you all
Chris,
for the
yeah. Chris, did you also have a question since we are at it? I see.
No, I was just raising my hand when Basanta was still talking.
Okay.
Sorry.
Okay. Let's move on to Santosh. You have a question? I can see your hand.
Yeah, thank you, Rajiv. My question to Professor Bodo. Professor Bodo, you presented a very nice and informative in sediment transport processes in the Western Himalaya region. From your rich experience from the Western Himalaya, can you please enlighten us a little bit on the what could be the prominent research questions for Koshi in terms of sediment-related issues? It's because the Koshi is a very high sediment load basins. And then you have already seen that some of the aggregations in the Indo-Gangetic plain is exceptionally high, and there is tremendous impact on the livelihoods. So how do you see that? What could be the potential ways to go ahead to understand, better understand the sediment in the Koshi Basin?
So if I look at the Koshi Basin and the work that we have done in the Arun, where we trekked up the Arun from the lower pass to the Tibetan border to sample along the Arun Valley, one thing that we certainly noticed is that the soil thickness is much thicker than in the Western Himalaya. So we do have a much thicker soil layer, which is a function of the higher rainfall rates that we observe in the Arun Valley. So the weathering there is higher, which tells me that the sediment flux from these vegetated terrains tends to be fairly high. You have a higher or you have a thicker non-cohesive layer, and that was my question with the slow-moving landslides. My expectation and observations that we have done in the Arun, and I'm only limited to the Arun. That's where I worked several years, but I haven't been in the western part of the Koshi Basin. We observe a lot of slow-moving, slowly migrating hill slopes that not necessarily result in catastrophic slumps that can be triggered by earthquakes or by big rainfall events, but you essentially have a continuous downslope moving hills. And that was one observation that tells me that the potential for sediment production is pretty much everywhere where you have that several meters thick soil layer. So I guess the question that I had with the slow-moving landslide was, with the modern satellites, with the modern satellite facilities, either with high-resolution optical or with synthetic aperture radar, you can establish a monitoring system that would tell you at what rates these slopes are moving, so that you would have a better hazard potential where the next big rainfall could trigger movement. So what I learned as well from the Western Himalaya, as well from the Central Andes, is that with the continuous monitoring, you see a speed up, you see the movement, the downslope movement, synthetic aperture radar. We now have 4 to 5 years of data available that would allow you to, generate a more complete picture of where in the next decades sediment can be produced. We don't want to look into the next season. We need to see where in the next decades the sediment can be from.
Okay, thank you.
Okay, anyone else? I guess we are almost about time to close this, but I can see one more hand. Yes, please go ahead. Yeah.
Professor Sinha, there's one question in chat box. Shall I address or?
Oh yeah, please. I didn't see the chat box for a while, but yeah, please go ahead. The question is if. Yeah. Okay. Yeah. Go ahead.
I think there are 2 questions. Probably directed to me, one from Suman Swester, another one is Hong Ling Tian. So basically the early warning system, the details my colleague Prakash Singh Thapa will introduce, but the concept is very low tech and low cost. So we only installed rain gauge, soil moisture sensors and extensometer. So it's very low tech. So we gave a training, 2 days training there, and then once handled to the local community, they could able to handle themselves, and it was very, very effective. And so from the Hong Ling Tian, actually that's why we don't need that much high technical portion there in the field. It's a very simple techniques, not high tech like the differential GPS or something like that. Not satellite connection, is connected with the telecom GSM network and just monitoring data transmission to the mobile phones and the system. Thank you very much.
Okay, thank you. So thank you very much to all the 4 speakers of this session. It was a very, very interesting session. We covered a lot of ground from the basic and fundamental processes to hydrology, to sediment fluxes, and then of course to the modern tool. We also covered a lot of ground in terms of the time scale from the modern day processes and all the way down to the Holocene scale, time scale, Holocene scale, erosion rates and so on. We also covered a lot of ground in terms of different parts of the Koshi Basin, and of course we had a very interesting talk from the Western Himalaya in Satluj Basin, and I'm sure many of those things can be applied in the Koshi Basin as well. These are some very interesting future areas of research as well. So I leave at this point, and I will hand over to Subina to take us to the next section. But I would certainly like to request all of you to stay on for the next 2 sessions. And the next session particularly is going to be very interesting in terms of the best practices, and then that will be followed by a panel discussion. Thank you once again, all of you.
Thank you so much, Professor Sinha, for facilitating the session. We have one more question from Mandira ji, and I would request Basanta ji to please address it in the chat box as we are running out of time. Before we move to the next session, I would like to request everyone to please turn their cameras on so that we can have a group photo. Yeah. And I would like to request Reyes to please make the logistical arrangements for the photo.
Okay, everyone, please turn on your video. We'll take a group photo.
Oh, that's a good idea.
Yeah. Okay, everyone.
Cheese.
Still few more to open the video.
Finish.
Okay. Last chance to turn on the video. Otherwise, we'll be missed. Okay, over to Reyes. Yeah.
Please keep smiling for 5 to 10 seconds.
Yes.
Okay, thank you all.
Thank you, everyone. As we are little out of time. I would now like to request Badriji to please facilitate our second session, which is on best practices. Mr. Badri Raj Dhungana is the Deputy Director General of the Department of Forest and Soil Conservation, Nepal. And prior to this, he was Provincial Secretary of the Ministry of Industry, Tourism, Forests and Environment at Province 1 in Nepal. So please.
Namaste. Thank you, Subina ji. Me, Badri Raj Dhungana, Deputy Director General, Department of Forest and Soil Conservation. Thank you for the entire team of ICIMOD for providing this opportunity to facilitate this interesting session. Today's afternoon session was mainly focused on landslide and sedimentation, and previous session was more on research themes. And now we are moving to the next session. It's a more focus on applied practices, best practice. And one practice is from the middle mountains of Nepal. Another is from our professor from IMH, China. It's maybe from upper higher mountains and the transboundary areas. And another is from the community-based sedimentation management. It's experience from Churia region and the lowlands of Tarai, the Ratu river system of Nepal. That's why we are running out of the time. It was scheduled for 3:15. Now it's almost 3:30. That's why without any delay, I would like to request Mr. Prakash Singh Thapa, Under Secretary, Department of Forest and Soil Conservation, to present his paper on landslide early warning system. And Mr. Thapa is Under Secretary working at the Department of Forest and Soil Conservation, Bawarmal, Kathmandu, Nepal, and he has been working in this field of watershed management and natural resource management for the last 10 years, and he holds the master's degree in forestry science from the Tribhuvan University, Nepal, and he's going to present his paper on develop community-based landslide early warning system, its experience from pilot projects of Nepal. Okay, Prakash ji, go ahead. It's your time is about 12 minutes for the presentation. Thank you.
Prakash ji, तपाईले unmute गर्नु पर्ला. We can't hear you. Prakash ji. प्रकाश जी, तपाईको माइक अनम्युट गर्नु पर्ला, हामीले सुनेको छैनौं.
Please unmute Prakash ji. We are not listening you.
Prakash ji, please leave the meeting and rejoin again.
Okay, looks like there is some technical issue. Badri sir?
Badriji, it looks like we have some technical issues. So I would like to please, go ahead and invite the next presenter.
Okay, Prakashji, what's the problem? Please wait for to resolve your problem. Then I would like to invite the next presenter, Mr. Dr. Hong Ling Tian, professor from the Institute of Mountain Hazard and Environment, IMHE, Chengdu, China, and his topic is multidimensional information for highway hazard evaluation and monitoring. Please, Dr. Tian, you can present now.
Okay, hello everyone. I'm glad to take this activity and meet so many experts from so many countries. Okay, I need to share my. Oh, I can't find where to share my PowerPoint.
There is a arrow sign just beside the leave, the right mark, if you have noticed, on the right corner on my.
Okay, I find.
Okay.
Yeah,
we can see it. Yeah, please go ahead.
Okay.
Yeah.
Let's begin. So the title is like this. I want to emphasize on the data. And for many countries, there are many landslides happen and generate great losses to local people and some road and highway. So here I want to show you the risk concept. As someone has known, the hazard is especially be in emphasis of researchers and professors, but some local people and administrative they like to keep point focused on vulnerability. The vulnerability including two parts. One is exposure, and the second is resistance. As shown in the two pictures here, we can see a landslide affect the highway, and because the highway is just below the landslide, so the position is very important. Now, the second I want to show you is what is a hazard. Here from the picture, we can show two close debris flows. The left one just buries the road. Because of the culvert, the tunnel is small and the debris flow cannot get through. And the right one, debris flow just bypass because the grade is high and the debris flow can go through the part. And from this picture, we can get clearly how the road and the position with the landslide. And the exposure is very important for a landslide catastrophe. Next, I will show you some location of landslide and road relation. And the left one is landslide in Pakistan, KDKH. And you can see the road is on the bottom of the landslide, and it's threatened by the landslide. And the middle one is in China, just in this August. And also, the road and some building was buried. The right one is in Japan, in and on top of the landslide, and the road was broken. Similarly, we can see in China, especially in Sichuan province, there are similar situations like Nepal, like in Koshi Basin. In China, the left part is Capital Plateau and the Yungui Plateau, and the middle part of this network is Sichuan Basin. In this transition zone, there are many landslides. So the road network will suffer from landslide. And next, I will show you what makes a successful monitoring. Someone will think maybe sensors, a network, or module is more important for successful monitoring. But from my experience, I think the data is most important. And with more and more sensors and remote sensing image, we get more data. But if the data is not adequate or just focus on the surface without insight information, it's difficult to pre-warning good. So the data including many parts, as other professor has talked about. The remote sensing is very important, and position I want to talk about is first important. Now we use high precision positioning technology like RTK and PPK for good position, which position can reach to millimeter or centimeter. And next is the coverage rate of monitoring data. As shown in the left picture, the 3 sensors cannot cover all the slope. So we use the LiDAR technology to get the surface data. And with different source data, we can cover all the surface. And the next one is the disaster phenomenon detect. Many researchers have showed the INSA can give us some deformation data. We have detected the deformation of debris flow and landslide in the left side. Here, the red one, we can see the investigation, the cracks is very obviously. And the remote sensing technology is popular. But how about the slope? Inside the slope, here is an example we used in Pakistan. We just talk about the KDKH landslide. We use ERT to get the inside structure. And the right bottom shows we combine different geophysical data and borehole data to get the precision structure of slope. And after that, the time is very important for disaster monitoring. So when did a landslide occur? Here is example we used in China. And in 2018, 2 landslides blocked different river. One is landslide block Jinshajiang River, and the second one block the Yaluzang River. we can see the different seismic waves.
8 minutes are up.
Okay. And with this data accumulated, we can give a good evaluation and monitoring. Here we can show the debris flow assessment. We get very detailed data of rainfall. Actually, there are no monitoring sites here, so we get the rainfall data from NASA satellite. And with this data and UAV image, we evaluate the highways debris flow. And here I provide some monitoring examples in Sichuan Basin. First one is Javanco Landslide. Here we found the cracks on slope in 2015 and set up the monitoring system at the next year. And after half year's monitoring, the slope moved very obviously, and we get the clearly data. The second one is Himalaya in KDKH. I have showed you. The third one is in Zhonghai Village. It's building Ehan Highway tunnel and caused the landslide in the middle picture. From the right one, we can see the monitoring data is very clearly. And in the left one, we can see there a landslide occurred in the August, and they are so close. The fourth example is we monitoring the debris flow in Hetao Gully. Here is the railway bridge, and the debris flow get down from the gully. We got the warning message before the rain come. It's a successful pre-warning. So the conclusion is here. The landslide risk for highway in mountain area is made up by hazard, vulnerability. And the second one is a fully slope information, including many fields. The often used data is part of them. Short of 4D data made the wrong or lack of recognition of hazard. And the third one is discussion. The new technology for data acquisition is increasing. The spatial temporal symmetry is obviously. And the last one is with more data accumulated, how to deal with the big data efficiently is very important. Okay, thank you. That's all.
Badri sir, you might need to unmute.
Thank you, Dr. Tian, for your nice presentation. It was more informative and more research-based, and use of ground penetrating radar, LIDAR, and other many sensors, and all the new technology for the acquisition of slope data for along the highways. That's why we could manage the or access the vulnerability or risks of landslide. Now we have about 3 minutes for queries. If the audience have any query to Dr. Tian's presentation, please put your questions, please.
Badri sir, there is already one question in chat section by Mandira Shrestha. So Dr. Mandira, if you want to read out the comment, or we can also do that.
Yeah.
Dr. Tian, you can
Shall I do it?
Yeah, please.
Yes. So thank you for an interesting presentation, Dr. Tian. You mentioned about the use of satellite rainfall estimates like TRIM and GPM for landslide monitoring. Now, we realize that TRIM and the GPM data sets have a lot of bias. So in your analysis or in your modeling, what kind of bias correction did you apply for applying it in landslide monitoring, and how well did it really, help you in terms of real applications that you've shown in the monitoring of these risks, the landslide risks in the highways? Thank you.
Actually, some technology is not very modern and already used by some people. And so monitoring including two parts. One is by sensors. We can get instant message of the deforming data. The second one is like geophysical technology. We use it to investigate several times in 1 year. Maybe before the rain season, we check one, and after the rain season, we investigate the other time. And when we got the two-time image, we can compare the structure is changed or keep the same. That's what we did. Maybe it's ordinary for some people. So it's my answer.
But did you apply any bias corrections? You said you used, the satellite data information for rainfall, because everywhere rainfall information is not available. So when you use the satellite rainfall estimates and information, did you make any bias corrections to your satellite rainfall estimate for monitoring of those landslides?
Yes, of course. In some places, there are monitoring rain gauge, and we can get the first-hand data. But in some places, when a landslide occurred, there are no data of rain and other data. So at this time, we will choose the close position to get the monitoring data, compare with the satellite data together to see if the data is maybe have a big difference or similar. And that's the framework.
Okay, thank you, Tian, for your response. I think there are no more questions on chat box and also no hand raised on my, I could not see any hand raising. That's why I would like to conclude this presentation of Dr. Tian, and thank you, Tian, for your presentation and response. Thank you very much. And I would like to, as we are moving out of the time, that's why I would like to switch to another presenter. If Prakash ji is ready and he has solved the problem, I would like to invite Mr. Prakash Singh Thapa. Prakash ji, are you ready? Prakash ji. I think he could not resolve his problem. Prakash ji.
Prakash's microphone is unmuted, but we can't hear him.
Please use the free microphone of your laptop. Prakash ji, are you trying?
But sir, maybe I'll try to call Prakash ji and try to understand the problem.
Okay, then I will go to the another presenter because we are running out of the time. It's almost near to 4 and it was to we have two presentations. That's why I'd like to invite Mr. Nagdev Yadav and Mr. Sushil Dhakal. They are going to jointly present their experience on soil conservation, watershed management, river system. It's more the topics is CD Community Development and Advocacy Forum Nepal's practices in controlling sedimentation through natural resources and river system management along the Ratu River and experience from upstream to downstream in the Churia landscape of Nepal. Mr. Yadav, who is the chairperson of this organization, Community Development and Advocacy Forum, and he has a long experience working in the field of natural resource management, especially soil conservation and watershed management in that region, especially in the Churia and lowlands of Tarai, in river system management. And his organization is a community-based organization. It works with the community, and they have a multi-sectoral working experience from this organization, and now he is going to present his experience in the field of soil conservation, watershed management, and sedimentation management in the river system. And Mr. Dhakal, who is the executive director of this Community Development and Advocacy Forum Nepal, who is Barbibas Mahottari based organization. It's in the central part of Nepal. Now it's in province 2. In Mahottari district. Now I would like to invite Nadev Yadav and Mr. Sushil Dhakal jointly to present their paper. Thank you.
Okay.
Go ahead.
Thank you, Bodhi Dungana sir, as a facilitator, and good afternoon and welcome everyone for this particular presentation on the CDFN's best practices. That we are here, Nadev Yadav as a president and Sushil Dhakal as an executive director, as Dungana sir said. First of all, greetings for everyone from our side.
Namaste, I am Nagdev Yadav, President, and good afternoon, everyone. Thank you.
Dungana sir, just I would like to ensure whether we are listening well.
Yes. Go ahead.
Okay, thank you, sir. As you have just mentioned our particular topic on our best practices in controlling sedimentation, this is what the first slide shows. That the different partners and donors were involved during the process of this controlling this river system management system. So we would like to acknowledge them all from this particular slide. I will just move on to next slide. Here we can see the physiographic location of Ratu River system that you can see in the green shaded areas are like Churia area, and the yellow shaded are Bhabur, is in between Tarai, the plain region, and the flooding region, and the Churia region, and the next one, this pink shaded area is our Tarai region. This is the physiographic region of Ratu, particular watershed where we actually worked through our best practices model, and we divided into 3 categories, that upstream, midstream, and downstream. And, if you see the upper Ratu watershed river system, that you can see the the main water river system of Ratu, and there are so many torrents and gullies that the 4 to 7 kilometer length of this gullies and running and collecting into particular river system, that is Ratu. So there are so many torrents, around 103 out of torrents. We have worked with 67 torrents, and 52 are almost established in this situation. These are the particular area where we worked, and these are Google Maps that we worked in our technical, through our technical team during the process of this project implementation. And you can see somewhere in the vegetable farming area, rainwater harvest areas, and then upper stream area, middle stream area, and different bioengineering model area. Also worked on this community-based for early warning system model, that if you manage to flow the information from upstream to downstream areas, people will cope with this particular flood and be safe from not being inundated. So this is also the physiographic areas of Ratu, and there are so many community forest user groups where we worked along the river system. And basically these 5 models you can see The first one is conservation of flash flood, torrent to rainwater harvesting ponds. That we actually work with different torrents and gullies in this particular model, where a series of dam and retaining wall were constructed across the torrents, and we try to stabilize this, the flowing of water and minimize the flow and this velocity of water flow. We try to minimize so that the velocity will decrease and the sedimentation will decrease from the downward side, and at the end of this system there will be pond, water conservation pond, from which we can use that in particular livelihood system, irrigation, and vegetable farming, and also for the recharge water of the groundwater recharge system. It will help for the groundwater recharge system in this particular model. And you can see some photographs, and the previous, it was like too much water, landslide, flood. There was the problem, and the sedimentation of debris in downstream, which hide the risk of flood and wastage of rainwater. And we have utilized this mitigation approaches, and finally the certain advantage like water availability throughout the year, and control of flood and landslide, and agricultural farming. And these are some benefits that we gain from this particular rainwater harvesting ponds, this first model. And these are some scale-up activities where we have worked with rainwater harvesting ponds. And if you see in the data, like we have almost 70 plus hectare of land irrigated through this water harvest pond, and 427 households are benefited for this particular model. And these are also some there are some scale-up activities. You can see the one example I would like to just mention here, like earlier the discharge of water for this particular tank was small in volume. Later on, when we establish particular this rainwater harvest ponds in different series of rainwater harvest pond in the Churi areas, that the water discharge the rate has been increased up to 38 liter per second from being 26 liter per second. So this is like kind of results we have demonstrated. And the next model, this raging seepage water raging technology. From this we construct kind of this technical this masonry and loose masonry wall across the river system, so that the flowing of underground water has been raised, and it can be utilized for the irrigation of round the year. So this is like another and this is its model, and you can see the hectare of land has been like irrigated, and then total household benefited, and total length of the canal that we constructed like around more than 30 kilometer in total. These are some photographs that we constructed in this particular river system, and these are like linked with the livelihood approach. That three crop cycle has been established, and it is like operating these days, 3 crop system. Earlier it was like 1. And the next one is rating of seepage water in torrents areas for drinking purpose. This is another kind of innovation that is similar as what we used in the irrigation system. Utilize the ferrocement tank in the different torrents, and we try to stabilize the torrents from the construction of walls and all, and we collect the water in particular reservoir tank and utilize for drinking. And this is another approach. From that we try to stabilize the sedimentation.
8 minutes are already up.
Sorry?
8 minutes are already up. You only have 4 more minutes remaining.
8 minutes, okay. These are some models. These are some photographs. And the next 4th model is bioengineering. From this, we utilize the low-cost bioengineering models to control and stabilize the different gullies and torrents, and together with plantation and masonry system. And as I told earlier, that 100 out of 103 torrents, we have like 67 has been, 52 has been already established, and we worked for 67 torrents. And these are some before-after photographs. You can see that what was in earlier and what was in later on after our work. And the last model is like, this river-based vegetable farming and fruit plantation, that the colossal patches of river beds like was earlier in, in the inundated to those areas and river banked are now converted into a fruit orchard or vegetable farming patches. So it is like directly linked with the livelihood and food security issues. So these are all downstream side of Chure, which we call Tarai. So around 1100 hectare has been like utilized for this particular model, and people are like gaining and working for their food security purpose. So these are some photographs, and these are our stakeholders and province and the federal governments. They were interested to visit our sites, that what we are working in Chure conservation and prevention aspect, and you can see some workshop has been organized, and they also visited our working sites and different funding partners, donors, and our stakeholders visits. And our earlier president, first president, Mr. Rambarn Yadav has visited. Since we, also work for this particular president Chure conservation project, so he was very interested to visit our locations, and this has been organized. And we also received awards, first awards in 2019, 2 different awards, and we are in the first position. This WWF Conservation Award and Adaptation at Scale Award, that is UK award, and the prize money was 100,000 sterling pound, and another WWF award prize money was 100,000 Nepalese rupees. Thank you for listening us and giving us this opportunity to present in this this valuable forum. Thank you very much.
Thank you, Mr. Yadav and Mr. Dhakal, for very nice and informative presentation, and it was a more experience-based presentation. It's not a literature or other based. It's a learning by doing experience-based presentation. Thank you very much for the entire team of this Community Development and Advocacy Forum Nepal. Dear audience, if you have any question and query, please put hand or put your query on the chat box. I could not see any hand raising or any question.
Thank you, sir.
Here is one query from Mandira Sreshtaji. Is the Chure Knowledge Center accessible to other region? It's initiated or it's proposed just? Could you do?
It is just proposed. There was one workshop organized, and the particular task force was formed, and some 4-point declaration has also been made. But they are the team is in working for this particular AKC Chure Knowledge Center establishment.
Thank you. No more query.
Yes, Badriji, I had one question.
Yeah.
Badriji,
Okay.
may I ask one question?
Yeah.
Yes, so I think very good experience and knowledge that has been gathered, particularly looking at water harvesting ponds and how that can also support in terms of runoff retention and alleviate some problems with regards to floods and erosion. Now, my question was regarding how this particular success story, but by the way, congratulations for so many awards that you have already received. How is this scaled out to other regions in the Chure? Because this is an experience from Bardibas and the Ratu River watershed. And how is this implemented, or is this how can this be implemented in other areas? Because there are so many areas where this could be implemented. The same problems there are in the other regions. Thank you.
Thank you for the question. Actually, in our context, from CDFN, it's on strategy or in its on working areas in Motor and Dhanusa, we have been also worked with Jangha river system. The same approach has been applied in Jangha river system and Aurihi river system also through different projects. But for replicating or making scale out of those, these best practices to other regions, we are also negotiating. I mean, we are also coordinating with this, province and other local governments, and they actually visited, observed our sites, and they were like really, interested. And at that time, they were also like committed to separate some funds so that we can like scale out those activities to other regions as well. But in Mahatari, we have been actually working and replicating those activities in other river system too.
Thank you. I think the experience you have gained, and you just mentioned that those 5 models, that is actually that was the combination of different issue conservation measures like structural measures, vegetative, and water management. These 3 themes. One is the civil structural works. Another, the vegetative works incorporated with that bioengineering functions, and then the management of water, especially that is the water stress area. Surya region and the upper Bhavar region is the water stress zone. Exactly. That's why you tried, or your organization tries 5 models, means that's the combination of different conservation measures, and its result has been judged. And especially the success on the torrents stabilization, mainly the torrents, ephemeral types of torrents are the problems in the Surya region, and also the use of the river reclaimed land after the construction of stream dikes or embankments along the river, and that land which has been reclaimed from the river bed, and that's the use of the other riverbed farming practice and linking it with the livelihood practice. That is the very nice. And now I request your organization to document all these things either in both in audio, visual, and then disseminate it with the like a government organization who are working in the region, and then Tarai Madhesh Surya Development Board, and other provincial government and NGOs, INGOs. That's why the same your success stories have been replicated in the many torrents along the east-west link of the whole Surya region from Mechi to Mahakali, and even it could be replicated in other part of India also. That's why it's very nice, and then I would like to request you to document it and make more dissemination of the knowledge to the other concerned agencies. Thank you.
Thank you, sir. Thank you, sir.
Thank you so much.
Actually, we have been published some booklets and success stories too. We have been published, and so much some publications were like distributed to particular dignitaries, government authorities as well. But of course, yes, sir. As you suggest, we will like further, further scaling up and make our documentation more properly. Thank you.
Okay.
Thank you.
Now we are running out of time. That's why I would like to thank you again and say goodbye from this presentation to you. Yeah.
Thank you, sir.
Thank you so much.
And now, Mr. Santosh ji, I think Prakash Thapa could not resolve his problem.
Yes, sir. It's really pity that we couldn't hear from him, but this is very unfortunate. Maybe we'll have another opportunities to hear his presentation in the future.
Sir,
okay, then we conclude this session then.
Badri sir, अहिले सुनिन्छ?
सुनिँदैछ? Yes.
हजुर, अलिअलि सुनिन्छ? भए मैले स्लाइड उता पठाइदिएको छु
मैले त राम्ररी सुनेको छु।
ए हजुर हजुर त्यसो भए
सन्तोषजी, आर यु लिसनिङ प्रकाश?
हजुर सर, we are listening.
Okay, now you go to your presentation and share your slides.
Santosh sir, kindly help me in this regard. Please share my presentation over there. Is that possible?
Yes, Prakashji, your presentation is up.
Okay.
Yeah, now sure. Yeah.
Can you actualize next, please?
Okay, सुन्न सकिन्छ हैन? Okay. Thank you very much and for the so we all know, sir, kindly please move to the
Prakashji, there is disturbances.
Yeah.
We can't hear you. Badrisha, can you hear him?
You echo is coming.
Yeah.
It's a problem.
Echo आइरहेको छ सर। म यो पनि बन्द गर्छु हजुर। ओके। सायद यो अर्को ल्यापटपमा खोलेको। ओके। मैले बन्द गर्छु सर यतापट्टि। Okay, so Santosh sir, please go to the next slide. I will continue and you can just move on to the next slide.
Okay, next slide.
Yes, we all know that Nepal is quite disaster prone country. While we come to experience different kind of disaster throughout the year, and basically more in the monsoon season. Floods, landslides, sometimes earthquake also. So we know that Nepal has a steep terrain slope, and our mountains are recently developing and having a dynamic state, because we all know that Indian tectonic plate and the Tibetan tectonic plate movement is happening. So Nepal is quite prone to different kind of disasters, especially landslide. When we talk about this landslide, if we see the data of the last year, landslide is the most life-taking disaster in context of Nepal. You can see now landslide has exceeded flood also. In early time or early years, we have experienced mostly flood problems in our Tarai region, but now in middles also landslide is becoming a huge disaster problem. So Department of Forest and Soil Conservation has experience in treating or in managing these shallow landslides, especially in mid-hills. So department is using structural as well as non-structural measures in the past as well. While seeing the structural measures, our previous colleague also presented different bioengineering measures, retaining walls, watling, some other different measures. But now in today's presentation, I'm going to express some knowledge about the non-structural measures, especially landslide early warning system. 2 years ago, from the FAO, Department of Forest established 2 piloting sites regarding this early warning system, one in Dolkha and another one is in Nuwakot. In Dolkha, Mehle landslide was selected for putting this early warning system, and in Nuwakot, Soreni landslide was selected. Both these 2 districts were quietly affected by the Gorkha earthquake 2015. While selecting these sites, good discussion with the community and the community leaders were done, and after that landslide susceptibility mapping was done for both the places. Dr. Basanta Adhikari was deeply involved in this process with us. So around 500 people in Dolkha district and around 400 people in Nuwakot were being benefited by the system. So while seeing the topography of the landslide, it was quite a slopey area in Nuwakot and the same in the Dolkha district. So before going to the early warning system, what we did as a bioengineering also, I would like to mention very shortly. So after susceptibility mapping, we just distributed that whole area into different zone based on the drainage system and what is the moisture of the area and what is the slope of the area. So based on this, different zonation was done there, and according to zone, different kind of treatment was given there. Some area are already in the safe condition, but some are in the very so we performed there some of the structural treatment like watling and some retaining walls, some jute netting, and some grass plantation, terrace movement, and some gully plugging. We check them. So Santosh sir, please go to the next slide. We can see different kind of structures I have already mentioned. Please to the next slide. These are jute netting, and yes, this is the watling. Please to the next slide. These are some herringbone structure for the water management. This is the recent pictures. Our DDG Badri sir also visited last week to the area, and we can see that the bioengineering structures are well grown. These Amrisho plantation together with other different species are very well grown, and the landslide is almost about to in the established condition. He is one of the ward member. So let's move to the early warning system. These early warning system are established in both the sites, and some instrument that we use to measure landslide movement is extensometer, some soil moisture sensor, and a rain gauge. Rain gauge is especially for knowing what amount of rainfall is happening in the area. Soil moisture is to measure the moisture that is under the earth or under the soil mass, and similarly, if any movement happens in that area, extensometer or 4 extensometer were used in Dolkha, and 3 extensometer were used in the Nuwakot landslide. So these were the structures used there. In this slide, we can see that the simple steel pegging in different portion of the landslide. This landslide is almost 160 meter. So we divided this landslide into 4 portion, and according to that, 4 extensometer with the wire was used there. Please next slide. These are some of the slide of the installation of this system. So please to the next slide. This is from Nuwakot. Earlier one was from Dolkha. These are the simple tools used. One solar panel. Solar panel was for the battery purpose and providing the regular power supply. Similarly, these are for extensometer to measure the any movement, and we can see that simple structure inside it also. Using these methods, we hired one caretaker to see all these phenomena in the field also, and we put some threshold. In the next slide, we can see the threshold used for these instrument like rainfall, soil moisture, and yeah, please the earlier slide. So if any threshold is exceeded, then a siren is blown, and similarly SMS to the 10 peoples was sent in that time. So we can see here in the slide also. Yeah.
8 minutes are up. You have 4 more minutes.
Okay, now so these are the threshold used for the rainfall, for the moisture, and for the movement, and the siren type. In slide we can see that if only small movement is there, then first siren will be blown, and if there is more movement, more threshold is exceeded, then the second siren, and similarly third siren will blown, and these siren have their own meanings. Now please to the next slide. There is one story from the Dolkha landslide in the month of August in 2018. There was a huge rainfall, and at that time the siren was blown, and that landslide also breached. So there was huge landslide in the Dolkha. It is the same place where we put our early warning system. During that period, what happened? All those families were system was of this galvanized steel roofing system, and that slide happened in the night time. So these people, some of the people, those who have cemented or this cemented roofing system, they listened this siren and they informed other people, please move out of your home and let's go to the safer place. That happened, and this siren system saved 117 families almost, and no casualty was there, but 2-3 household were damaged. House were damaged. So this system saved there. And other thing that we conducted there is awareness and capacity building in those areas, and safe house was also built there. So some of the learning that we find is it is important tool for landslide risk minimization. However, this landslide early warning system may provide a false sense of security that we have already installed landslide early warning system and now we are safe. This kind of feeling may generate among the local residents. So landslide could be only aided tool for the landslide management. Other structural and bioengineering things we should conduct there. Instrument installation sites should be very stable, otherwise it will not function properly. Regular maintenance is needed, and backstopping to local community is very necessary. Involvement of community in the early warning system process is always important for the sustainability of this kind of system. Early warning system is not very expensive. This is only around 4,000 to 5,000 US dollar costly. So we can replicate this kind of system in other area also. And it could be a kind of tool or approach for the community-based disaster risk management in context of Nepal. With the acknowledgement of our DOFSC and FAO, I would like to conclude my presentation. Thank you for your passive listening. Thank you, sir, madam.
Thank you, Prakash ji, for your nice presentation. You could not present due to technical problem. Now you concluded it. Thank you very much for your presentation. There is one question from Mandira Shrestha ji. How was the threshold determined? Could you explain a little bit about the threshold on that rainfall threshold which you show in your slide?
Okay. Thank you, sir, and thank you, Mandira ma'am, for your important and valuable question. I have mentioned this in our slide also. This is modified after Dahal and Hasegawa 2008 and JICA 2009. They have done this kind of study for the road construction in the Mugling Chitwan road highway in the Kabilas village, and it is some help from the Yin et al. And Segnoi et al. 2018 and 2010 was taken for calculating this kind of relationship. Because in context of Nepal, this rainfall is calculated, but moisture and movement has not been calculated. So we try to take reference from other countries.
Thank you. Yes, for clarification.
Thank you, sir.
Is there any other comments? One is about the sustainability. One Rajendra Bahadurji has been how sustainable it is. Who will continuously look after it about the early warning system, I think.
Yes, this is very important question, and yes, while we were in the process of establishing this kind of early warning system, at that time we have our field offices also. But after this federal restructuring, we handed over those to ward from the respective municipalities or rural municipality. So ward chairperson and ward members are mainly responsible. And at that time, we supported them for the 2 years for hiring caretaker and provided some backstopping. In current time also, mainly the ward office is the responsible after our installation. Yes. But in the meantime, we are also visiting to those places what is happening. And I want to mention that this year also we are trying to install early warning system in 1 or 2 places with the learning that we gained from these 2 areas. And hopefully within this month, we'll be establishing 1 early warning system in the Konjosum rural municipality of Lalitpur district. That will be very nearby, and we thought that this will be one learning site for other person also. Thank you.
Badri sir, तपाईं muted हुनुहुन्छ, unmute गर्नु पर्छ sir.
Sreshth Ramesh ji, if any government or non-government organization is interested to buy and install that equipment and device, where we can get it? It's a question. Is there any supplier or vendor available nearby?
Yes, sir. During last year, we also published one brochure or a leaflet in our department. Also, you can get that very easily. Based on that, you will also get some information about that. And other thing, you can contact me also directly to know about the supplier and where you can get this kind of machinery. And some other persons are also working in this regard. So I can provide you more information. So you can directly contact me at this point of time. I will tell about the more vendors and suppliers.
Thank you. I think there is no more question. We are running out of time, and that's why I'd like to conclude. Okay, Santosh ji, let's conclude now. Oh?
Thank you, Badri sir.
For this entire session of this afternoon, it was scheduled to start on 3:15, but we started at around 3:30. Then it's almost 1 hour gone. In spite of this technical hindrance, we concluded all the 3 sessions, taking about 1 hour instead of 45 minutes. Let me thank again to all the presenters of the 3 themes, Dr. Tian from China, and Mr. Nagdev Yadav and Sushil Dakal from Kotphan, and Mr. Prakash Thapa from DOFSC. All the 3 themes were experience-based presentation, and it was on the landslide and sedimentation management and early warning system. It was more related with the different aspects of landslide and sedimentation. And Mr. Tian's presentation was more technical and use of new latest technology like LIDAR and underground penetration radar. Like these things, I think it's quite new for us, and we hope like a country like in Nepal, in the mountainous road network, it could be applied in one or few places as a trial, but we could not use it in many places. But that is a new technology that came with, we could know the thing. And similarly, the Nagdev and Sushil Dakalji presented a nice presentation about the current management, especially in the Churia region. That was experience-based learning. And then the Prakash Singh Thapa's last presentation about the development of community-based landslide early system. It has been applied in a few small-scale landslide, and it's a low-cost method. It does not cost much, but it's just to save the life. It could not save all the physical properties damage, but it gives siren, gives the alarm to the people to go to the safe place. That's why they could save their life in case of emergency. That's why it could be applied in our context, I mean, future also. With this, it's a nice session about this landslide and sedimentation management. Now I would like to thank all the presenter, all the audience and the organizers and ICIMOD team and the host for this session. And again, we would share these learnings through the proceedings of this webinar in the coming days, and we share among the stakeholders and the participants in the days ahead. With these remarks, I would like to thank all and conclude this session. Thank you very much. Thanks to all.
Thank you so much, Badri sir, for facilitating the session so well despite the technical difficulties that we faced. As you said, we're running out of time and we are on an extremely time crunch situation. So I would like to quickly invite Dr. Santosh Nepal to continue with the session and moderate the panel discussion.
Thank you, Sabina. And I would like to again welcome you all in the last part of the session, the panel discussion on transboundary cooperation. While we set up the next session, if you'd just like to go and grab tea or coffee, please feel free to so. It might take like 2 minutes. So I request all my esteemed panelists to switch on their video, and I will start the session very quickly. Rajiv and Badri sir, you are already on. Professor Chen Ning Chen.
I'll join in 2 minutes.
Okay. Professor Chen Ning Chen and Dr. Rajendra Prasad Bhandari and Ms. Kripa Srestha is already on. Professor Chen Ning Chen, can you please switch on the video? And Dr. Rajendra Prasad Bhandari, sir.
Here.
Okay, Rajendra sir, if possible, please switch on the video, sir.
Okay.
Mandiraji, your hands is raised. Is it like a new hand or your old hand?
Pretty much my old hand there.
Okay. Thank you, Mandiraji. Okay, I'm just requesting. I cannot hear from Professor Chen Ning Shen. Professor Ning Shen. Subina, can you please check if he's in the attendance list? Okay, I'll start the session because we're running out of time. And welcome to this panel discussion on the need for regional cooperation on landslide and sedimentation research in the Koshi River Basin. The focus of our panel discussion is to understand the present state of collaboration on landslide and sedimentation research in the transboundary Koshi River Basin, and what are the challenges in present time and how we should enhance the regional cooperation. And also in the context of the present Koshi Disaster Knowledge Hub, and I will also request our panelists to suggest how the KDKH Hub can play a role in this effort. And at the end, we'll take some questions from the participants. These are our guiding questions, and I would like to introduce our panelists. Professor Rajiv Sinha is the head of the Department of Earth Science, IIT Kanpur, and he was already introduced in the morning. For the sake of time, I will not read out the other achievements of Professor Sinha. You will hear him. And Dr. Badriraj Dhongana is the Deputy Director General of the Department of Forest and Soil Conservation, Nepal. And he also just moderated one of the sessions, so he was also already introduced. Professor Chen Ning Shen is a professor at the International Mountain Hazard Institute, IMHE, Chinese Academy of Sciences. His professional experience lies in the disaster prevention and reduction engineering, in which he has about 3 decades of experience. Dr. Ninsheng obtained his PhD in physical geography from IMHE and has authored over 125 publications. Then we have Dr. Rajendra Prasad Bhandari. He is the Deputy Director General of Department of Geology and Mines, Nepal. Prior to his current role, he was the Superintendent Geologist in the Department of Mines and Geology, Geoscience Division. Dr. Bhandari holds a PhD in Environmental Hydrogeophysics from Montana University and has been working in the field of hydrogeology for over 25 years. Last but not least, we have a very young female researcher, Ms. Kripa Shrestha. Kripa is currently working as research associate in my ecosystem with different initiatives in ICIMOD. She has experience working with different landslide hazard modeling and disaster risk reduction. She holds an MSc in environmental science from Tribhuvan University, and she is also one of the anchors of landslide and sedimentation transboundary working group at Koshi Disaster Knowledge Hub. I'm just trying to confirm. So, Rajendra Bhandari, sir, you are here, and Professor Chen Ninsheng. Can I hear from you, Professor Ninsheng? Is he in the participant list?
He's not here. No.
Okay. Somehow we are not able to connect him, but I will try one more time before I raise the question, because the first question is actually to Professor Ninsheng. Professor Ninsheng, are you here with us? Okay, very unfortunately we missed Professor Ninsheng, but I will ask my colleague Shubina to keep an eye on if he's online somehow, and then we'll try to raise the question to him. So I would like to go the first question to Rajendra Bhandari, sir, Deputy Director General of Department of Mines and Geology. Rajendra, sir, the department has worked on landslide-related issues. I've also found a landslide inventory map, landslide hazard map produced by the department. So how do you see the need of landslide and sediment research collaboration in the transboundary Koshi River Basin?
Thank you, Santosh sir. Thank you for inviting me to join this very informative forum. And actually, currently DMG do not have any collaborative landslide and sediment research project. However, DMG has regularly engaged in landslide assessment during and after each monsoon in order to suggest likely mitigation and relocation strategy to the government. That is the first thing. And then regularly we are monitoring the landslides. If some districts has raised questions about the settlements, whether these settlements is actually need relocation or not, at that time we immediately go there and try to find the solution. And this is one thing. And the second thing is I would like to add that from January 2021, it is about to begin the collaborative project with the Durham University, England, on preparedness and planning for the mountain hazard and risk chain in Nepal. This is the very good news that the collaboration are not actually only with DMG, but it has a lot of organizations involved from the government side and non-government side from Nepal, as well as there are several universities from New Zealand, Canada, and Australia in different parts of the world. They are involved in this research, and it will last about 3 years, I think. And the main theme of this research is contextualize the contemporary multi-hazard and systemic risk landscape in Nepal to understand how risk is produced, experienced, and negotiated by the household and communities, and transform earthquake planning processes into national scale preparedness planning for catastrophic multi-hazard events, and seasonal planning for monsoon-related and multi-hazard events for local government decision making, and at last, then embedding local, natural, and social scientific knowledge of the mountain hazard and risk chain in preparedness and response. This is the thing that we are looking in the next 3 years. Probably we might have success to get a good results to make the people resilient in the throughout the country, also in the Koshi Basin as well.
Yeah, thank you, Bandai sir. I'll get back to you, but it's very encouraging to hear about this collaborative research with Durham University, which also look at the local scale. Now, my next question to Badri sir. Badri sir, Nepal being in the midstream region, the China in the upstream in Koshi, Nepal in the midstream, and then the India in the downstream region. How Nepal can benefit from the collaborations among the three countries? If all three countries are working together for sediment and landslide related research, so how Nepal can benefit, sir?
Thank you, Santosh ji, for a nice question, and also providing this opportunity to take part in this plenary discussion. Again, good afternoon, and maybe it's time to say good evening to all the panelists and the audience. Regarding this Koshi Basin, it's a Koshi River, it's a transboundary river system, which, as we know, the many tributaries, it originates in the upper Himalayas in the Tibetan region, and it flows all the mountains through Nepal, and it ultimately joins the Ganges river system and in the plain of Bihar in India. That's why being in the middle part, but we have a narrow stretch in the midstream, but the topographic variation is quite high, about from 60 meter of lowlands at the Sunsari district in Koshi Bank to the highest altitude of 8,848 meter of Mount Everest. That lies in the middle part of this Koshi river system, yeah. As we consider the three upstream in the Tibet and midstream in Nepal and downstream in Bihar and India. That's why we have a very rugged and rough topography, and it's geologically the whole mountain region is quite young. That's why we do not have much knowledge on all the aspects of geology, hydrogeology, all meteorology, is because of this mountainous terrain, and we do have a very limited hydrometeorological station. We do have very little geological knowledge, and regarding this complex landslide process. That's why we do have mutual collaboration and cooperation regarding the themes on research, especially the sensor-based or remote sensing-based research, either done by the Chinese side or either done by Indian institutes or other researchers from the distant researchers, that could help us to do the policy guidelines for Nepal and also for the mountain to save the livelihoods of people of the mountains, peoples who are living in the catchment or the basin area of Koshi. That's why we have to share our knowledge, our technology, skills, and we have to exchange our information and data regarding it's a Koshi is taken as a sorrow of Bihar. That's why what's the rainfall and what's the big landslides is occurring in the mountains of Nepal, that has a direct influence or impact on the sedimentation of Bihar region of India. Yeah? That's why we do mutually benefit, we all three countries, all the South Asian countries will benefit from, even it ultimately these sediments reach up to the Bay of Bengal. That's why the Bangladesh is also a part of our but it's not directly related with the link with the Koshi, but it could be a part of when we talk about the whole Ganges system. That's why we benefited from this.
Thank you, Badri sir. I'll again get back to you. Now I would like to go to Kripa. Kripa is a young researcher working in Nepal on landslide. What are the challenges you are facing in your research endeavor? Can you please share your experience? I think it's very important to also listen to these young minds and young researchers. And Kripa, if you can also limit your the remarks within 2 minutes. Over to you.
Thank you so much. Basically, Nepal being a very tectonically active mountain, disaster prevailing in Nepal and many other HKH regions is very much common. I believe for the accomplishment of the good research at this stage, as I'm talking from the youth perspective, access to data, information and technology is crucial. Data sharing in terms of transboundary nation, as well as data access to the young researcher who is doing the research from their respective university. Let us consider a few high resolution data, which is very expensive for the student to access it for their research. And it is very vital to have a common platform where all the stakeholders, including the young researcher, be included, where they can learn from the experiences and the challenges and the success story that is shared by the different stakeholders, which has affected both the upstream and downstream communities. And considering the institution level, scientific institutions and university plays a very major role, and at the government level as well. And what I would like to focus here is a separate budget is very much important to provide the grant to the students to carry out the research in the basin, because there may be many innovative ideas there which might be hindered due to the budget issues. And each year, multiple research comes out from each of the university, which should be taken into consideration as well. And the research institute can also submit the concerned research outcome to the such implementing agency or the government for the evidence-based policy decision making as well. And lastly, being very precise, I would also want to emphasize on the capacity building of the young scientists and young researchers, as they play a crucial role in DRR as well. Sharing my experience from last year, I attended a training of landslide hazard modeling, which was organized by ICIMOD. And that was really helpful for me to work, and I'm still using the same technology and the modeling technique in my work now as well. And therefore, I would say that such opportunity for the young scientists, and both nationally and internationally, to strengthen the science, technology and innovation to support DRR and climate change and build resilience at the national, regional and global level is also important to consider. Thank you.
Thank you, Kripa, for a very concise remarks. And now I would like to come to Rajiv. Rajiv, you are responding towards the end for these particular questions, but you are also located in the downstream areas in the India, that what happens in China, in Nepal definitely affects there. So what is the importance of collaboration and landslide and sediment research being on the downstream nations? And if that collaborations happen with Nepal, India and China, can you please share your remarks within 2 minutes? Thank you.
Yeah, sure. Thank you, Santosh. I think it's very important to understand and realize that the processes we are looking at, landslides, sedimentation, floods, they're all very, very interrelated processes. And although they happen in different parts of the basin, but they are very highly interrelated. So we have already been talking about it since morning, upstream, downstream linkages, and so on. And this interlinkage issue becomes even more important when we are looking at a transboundary basin, because in one part of the basin which is located in a different country, the problem may be different and the mitigation strategies may be different, but the impact of those problems, those processes, as well as the mitigation strategies they are having, that might have an impact on the downstream region as well. And I think this is where the collaboration amongst the countries, people living in the different parts of the basin, that becomes really, really critical. A good example is the 2008 breach, which we talked about. Until about that time, we didn't really have a very good. That was probably one of the most disastrous event in the recent history. Landslides and floods have happened in the Koshi Basin for a long time, but that always reminds us what is the importance and the need for this kind of collaboration. The amount, looking at if you go back and look at the magnitude of the flood and the causal factors of the flood, you will feel as if it was a trivial event, right? the flood happened at a discharge which was 1/7 and 1/8 of the discharge capacity of the Koshi barrage, but then that affected, you know, a very, very large number of people. And I think that sort of tells us that, you know, it's not the magnitude and the frequency of the event which is important. What is important is going to be how impactful that event is going to be. And unless we share this information and the data amongst all participants living upstream and downstream, I think it is very, very unlikely that we'll be able to find a sustainable solution to solve these problems forever. You know, we keep talking about, I'll stop here for now and then we'll come back on this.
Thank you, Rajiv. I think a very important point that you have highlighted is the interlinkages, you know, the upstream and downstream. What happens in upstream affects downstreams. That's how the cooperation is required. My next question is around the transboundary collaboration is a challenging task, as we all know, and we are trying for this for a very, very long period of time. And there are lots of challenges at every level. So my next question is, what is the ideal collaborations in the Koshi Basin you can imagine? You can be imaginative as much as possible. And what are the challenges of achieving those ideal collaborations? So now we are not seeing the Professor Ninseng. I would start with Kripa. Kripa, when it comes to research, what young minds actually think is an ideal collaborations? What are the challenges that you see?
As we know that disaster does not consider any boundary, which I think itself highlights the importance of transboundary collaboration in order to reduce the impact of it. And I believe the regional collaboration would include the crucial step of sharing data, information, and technology. And we have been hearing from different panel discussion in this annual dialogue as well, and different presentation made by different experts today as well. Due to the technological gaps among different countries and the diverse characteristics of landslides, various technological solutions may be required for to mitigate the disaster like landslides, and technology sharing will help to optimize and enhance the technical capacity. And another point is inadequate knowledge has been another hindrance on achieving the goal. And for example, Nepal embarked upon the aggressive rural road construction policy that has led to the haphazard road construction and causing the blockade. During landslide is one example, and there are more landslides that has been concentrated in most of the highways. And geologists have been saying that many villages in Nepal are located in the old landslide, but people tend to forget very quickly. And at first, people start to grow the crops, and then slowly they start constructing the houses. And this is why there is a knowledge gap as well. And to talk about the HKH assessment report as well, which also highlighted the alarming risk of landslide in HKH region, have also recognized that the stakeholders, including the governments, like communities, locals, etc., needs to have the urgent action for enhancing resilience through 4 basic pillars. That is information, infrastructure, institution, and insurance. That includes ecosystem, gender, and livelihood perspective. So in future, what I imagine, or in future outlook, what I would see ideal collaboration would be incorporating all these points. And I would also see the young scientists and the young professionals using, while also enhancing their capacity to strengthen the science, engineering, technology, and innovation to support DRR and climate change, and also achieve the targets of Sendai framework for DRR at all the levels. Thank you.
Thank you, Kripa, for highlighting a very important point, and from knowledge to the stakeholders, also the young scientists. And now I would like to come to both Rajendra sir and Badri sir together from the perspective from the government side. So I'll first go to the Rajendra sir, then to the Badri sir. From the government side, how do you see the ideal collaborations? Taking example in Koshi, and how it can benefit to the government efforts on disaster risk reduction. Dr. Rajendra Bandari.
Actually, I couldn't tell you that how we can do the ideal collaboration, but one thing for sure, that if we have a continuous dialogue from the downstream country and upstream country, and the strong data sharing mechanism. If the government has established the data sharing mechanism, specific data sharing mechanism, then it is quite easy to share the data, the platform like what you have, and this is definitely works. And in the coming futures, we can able to achieve the ideal cooperation. Otherwise, I think it is quite difficult because there are different interests from different countries, and that's why to make it narrow down the interest, then it is a little bit difficult, and that's the big hindrances. For that, we need to keep dialogue and try to synthesize the data differently. Yeah. Thank you.
Thank you, Bhandari sir. Badri sir, would you like to again respond on this question?
Okay, thank you, Santosh ji. Regarding this question, ideal collaboration, it is hard to define what is the ideal situation. Nothing is ideal with the given condition and constant, and something would be, or any condition would be ideal with the given condition only. I think so. Not any situation will be ideal if you change the other factors, and that's why remaining all the things and externalities the same, something could happen, the ideal situation for that condition only. I do believe on that. That's why we could not say this is the ideal. But regarding this DRR and the talking about the disaster and whole the community and nation and internal transboundary issues, we should take I think the Kripaji also mentioned this river whole as an ecosystem. And within that ecosystem, ecosystem does not mean only the biotic factors, it's the working ecosystem or the river ecosystem. And what are the factors or key components or the key stakeholders within that ecosystem? And what are the externalities that we have to be identify, and then based on those things we have the condition of collaboration in many aspects. We do have a collaboration in technology, we do have collaboration in skills, knowledge, experience, and resource and innovation, and we do have the diverse natures of people within that ecosystem, and we have to work on the whole the benefit or the well-being of those peoples. And regarding this in Nepalese context, if we talk about the DRR, we do have first we have the inter-agency collaboration first within the different departments, different agencies, different government sector. We are talking now in federal structure, we are talking about the 3 tiers of government, central, province and local level, and with the and many stakeholders. There are many departments, many ministries, many organizations, many institutions. That's why we do have a common vision and common stand. We do have a different responsibilities, but the ultimate vision and the ultimate objective or ultimate goal could be the